About 8 years ago, I built this. It's an information panel that normally hangs in my living room, and it just shows me what the weather's like, my calendar, it shows me some news feeds, status of devices that I've got around the house, and also feeds from my various webcams. Now, here in 2025, 8 years after I built it, it's starting to show its age a bit. And this is going to be the start of a two-part video. In this part, I'll show you how I put this together. And in the second part, I'm going to bring both the hardware and the software up to date, so I can then run it for another 8 years. Let me show you how. Hello once again, Pi geeks and techno nerds all over the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pi since they first came out, and I wanted to share with you some of the projects that I've done along the way. If you like what you see on this channel, do exactly what it says on my t-shirt. Hit that thumbs up button, subscribe if you want to see more, and click that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project, and if you've got any ideas for other projects you'd like to see me do in the future, put those in there as well. 8 years ago feels like a whole lifetime. So much has changed since then, and that includes the Raspberry Pi. Back then, the Raspberry Pi 2 and 3 were widely used, and the original Raspberry Pi 1 was still available. I wanted some kind of device that I could hang on my wall, that I could look at to provide information about what the weather was doing, see stuff on my calendar, keep up to date with the news, and also see feeds from my webcams that I had dotted around the house. And so I put one of these together using a Raspberry Pi 2, a laptop screen, a driver board for that laptop screen, and some custom software to allow me to use buttons on the front of the device to do things like move to the next month and previous month on the calendar, refresh the screen, and also reboot the device. I then had a fifth button that was hooked onto the monitor control, and I could use that to turn the monitor on and off. Now, this was a great project, and it also allowed me to exercise my woodworking skills as well, or lack of, in order to build the case. It took ages to put it all together, but I was so proud and happy with the result, and it's been running really well for these last 8 years. But now it's starting to look a bit tired. The Raspberry Pi 2 is kind of old and not very powerful, and this sometimes leads to the webcam feeds kind of stuttering and sometimes failing. Equally, the most recent changes in the Raspberry Pi OS operating system for some reason have had a negative effect on the code that I wrote to drive the buttons. And so in this video, I wanted to go through that original project and how I put it all together. But then I'm going to do a part 2, where I refresh this with all new parts, including a touch screen, so I don't need physical buttons at all. So stay tuned for that, and remember to hit that subscribe button so you know when that part 2 comes along. But firstly, let's crack open this device so I can show you what's on the inside. Trust me, it's not pretty. Now, firstly, apologies here, I don't have a great overhead camera, so this camera angle's a little bit funky, but you'll get the idea as we go along. Now here, we're facing the back of the info panel, and so the first thing I want to do is take off that back cover. And there you can see the mess that sits inside. I did originally try to arrange this in some kind of way so I could mount things. It never really worked out. So through a combination of bodging stuff, bits of blue tack and some insulation tape, I eventually got things to be held fairly well, but over the years it's all come apart anyway. Now, one of the most important things at first is this part over here. This is the power connector, and for this I just bought a little DC female power socket, drilled a hole through the bottom of the case, and then screwed that in place. You can just about see the connectors here. And onto there, I've soldered 2 wires. Now those wires ultimately come up into this. It's actually a splitter, where it takes in that 12-volt supply and splits it into 2 directions. The first of those connections goes off to this. It's a 12-volt to 5-volt buck converter. And this is what I use to drop the 12-volt input down to the 5V input that the Raspberry Pi needs. And this then has a micro USB connection that goes straight into the Pi to power it. The other end of the splitter comes down into here on the monitor controller board, where this needs a 12V input. So you can see that barrel jack just plugging in here. There's then the main cable that connects the monitor controller board over here to the laptop monitor. And moving the laptop controller board over a bit, you can see that one of the buttons that I've got on the front side, I connect through onto the monitor controller board. Now this connector here would normally connect through to the front panel buttons on a monitor. And one of these is for the monitor on and off switch. So from the datasheet, I was able to determine which pins they were. And so I was then able to connect those round through into this button. You can also see the HDMI output here from the Raspberry Pi. And that goes off into the HDMI input of the monitor controller board. I then have these other 4 buttons here on the device, and they connect through to GPIO pins on the Raspberry Pi. Now in terms of exactly which GPIO pins are used here, I'll go through that later as I go through the software that runs on it. Now since this is a Raspberry Pi 2, it doesn't have any Wi-Fi built in. So this little USB dongle that you can see plugged in here is actually a Wi-Fi adapter, and that allows the Raspberry Pi to connect through to my home network. Now in terms of the construction of this case, I didn't want any screws and stuff to be visible from the front side. And so I've used cam bolts here, 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 and here to connect this front box piece onto the back side. So let's take that off. Now this box piece here was just put together by gluing 2 sheets of MDF together. And this was just purely to allow there to be enough room for all of the electronics to sit in the case and then allow a cover to be put on the outside. And this would then allow the panel to hang nicely on the wall. Now we just have another small sheet of MDF here, and that just acts as a separator between the monitor here that sits underneath and all the other components that need to sit within the box. Looking at the front side here, and apologies for the reflections from the glass, I'm just using some decorative trim around the outside of the monitor, and this is effectively what's holding the monitor in place. It's sized so that the edges of the screen, where there's no actual display, can then sit there in order to support the monitor and hold it in place. Now here I've got another one of these laptop screens. It was made by Philips, and the idea was it was used in old school laptops. Now if I hold it up vertically, you can see it's actually quite thick. And this was just a consequence of laptop screens at the time. Again, remember this was 8 years ago. But it is quite a nice compact unit, and so it is perfect for this particular job. Now one limitation of this screen is that it's got a maximum resolution of 720p, and so that restricts the amount of information that I can actually show on the panel. But as you saw at the beginning, I can still get a reasonable amount on there. Now the laptop screen in itself wasn't enough, I had to get the monitor controller board as well, and I found that this one made by LG worked just fine. Now again, if we actually look at the circuitry on here, it's quite tall. Some of the capacitors actually protrude from the board quite a way. And this meant that I had to make the box holding everything fairly deep. And that was a big downside to the whole project. But everything worked really well, so I can't complain too much. It's just purely that technology has moved on over the years. The various buttons that I've got on the front here are just very simple push buttons. I wasn't very confident with my soldering skills back then, and so these buttons actually have screw terminals on them. And with that, I could then just hold jumper wires in place with the screws, and then use the other ends with the female pin connectors to plug straight into the Raspberry Pi. So the only soldering that was required in this whole project was really just that required to connect the power connector. So that's how the physical box was built. But now let's go and take a look at the software that runs on it. Now there will be a link in the description to my GitHub so you can get all of the code for this. However, this is going to be one of the rare occasions where I'd suggest you use it more for reference only and less directly for your own project. The reason I say that is purely because there's going to be a part 2 for this, and a lot of this code I'm going to rewrite because there are some problems with it. But I wanted to share it with you anyway, partially just so you can see I've been through a journey as well. I don't claim to be a complete expert in all of this stuff, and this project in particular I was doing an awful lot of tinkering, so don't expect any of this to be really good, well-written stuff, and I'll point out where there are issues with it along the way. Now what I do here is I actually package up all of this software as a Debian package. This means that you can just build the package and then just install it straight on a Raspberry Pi. It makes life a whole lot easier if you have any situations like your SD card fails or something like that and you've got to rebuild it from scratch. Now there is a prescribed directory structure that you've got to create for this. Initially, you have to create a directory that is named the same as what you want your ultimate package to be called. In this case, I just want it to be called Info Panel. You then have to create a directory under there called Debian in all capital letters. And under there, strictly speaking, the only file you need is this file called control. And you can see the contents of that here on the right hand side. This contains the name of the package, version information, the architecture of the package that this needs to run on, and in this case this is very deliberately AMD32. Remember, I'm using a Raspberry Pi 2 for this, and on a Raspberry Pi 2 I can't run a 64-bit operating system. As a result, I can only build this package to run on a 32-bit environment. The maintainer information is just designed to give you an email address that you can go to if you have trouble, and this one isn't genuine, so don't try spamming it. I have some friendly text here just to describe what the package is all about, and then this last line defines all of the dependent packages that this one has. In this case, I need the Apache web server, PHP, and some other tools to be installed in order for all of this to work. Now, optionally with Debian packages, you can provide standalone scripts that will run before a package is installed, after it's installed, before it's removed, and after it's removed. And these would need to be named pre-inst, post-inst, pre-rm, or post-rm. In this case, I'm just providing a post-install script. And what this says is that anything that gets installed under /user/local/bin should be made executable. If we look at the files that get installed under /user/local/bin, the first one of these is kiosk.sh. The first lines here make sure that no screensaver is applied, so the display won't get blanked after a few minutes. The unclutter command here is used to actually remove the mouse pointer from the display. I then have two fairly ugly looking commands here. Don't worry about these too much. All they're really doing is providing some configuration for the Chromium browser. And what this is doing is just ensuring that if the browser happened to crash last time that it ran, I'm clearing out that metadata so you don't have any irritating pop-ups come up asking you if you want to restore your configuration or anything like that. It's a bit dangerous, to be honest, and not a great thing to do. It's certainly not good practice. I then run this Python script in the background called switch.py, and this is what takes care of all of the button presses and its interaction with the GPIO pins on the Raspberry Pi. The last line here actually launches the Chrome browser. The most important option is this one that says --kiosk. What this does is it starts Chrome without any menu bar being displayed or title bar, and so the actual web content runs full screen. I then just get this to load up the local web page that's served up by the Apache web server installed on the system. Now let's look at this switch.py function. The first thing this does is it sets the GPIO mode to BCM. There are two different numbering schemes for GPIO pins on a Raspberry Pi. The BCM model seems to be used more than anything else, so I set it to that here. I use 4 GPIO pins here. I use pin 20 to trigger a page refresh, pin 21 to trigger a reboot of the whole machine, pin 16 to go to the next month on the calendar, and pin 12 to go to the previous month on the calendar. I set all of these up as input pins, and I apply a pull down resistor so that by default they're all low. Now here I want to keep track of what the last value was that I read for each of these pins, and so I keep those in these variables here. I initialize them all to 0. I then enter an infinite loop. The first thing I do in this is I take readings from all of the keys to see if any of them have been pressed. I then apply the same kind of logic to each. But using the refresh button as an example, I basically say if the old reading was 0, the new reading is 1, and so the refresh key has been pressed. I then trigger a call to the xdo tool command to simulate pressing the F5 key on the keyboard, and this will cause the screen to refresh. I then update the value of the previous refresh to be whatever it is currently. This works in a similar way for the reboot, next and previous functionality. The reboot button will trigger the command sudo -s/sbin/shutdown -r0 to be called, and this will actually cause the Raspberry Pi to reboot. The next and previous button handlers use the xdo tool in the same way as the refresh button handlers did to simulate pressing the keys N and P respectively. Within Google Calendar, this will respond to this by moving to the next month or the previous month on the display. I then apply a slight pause here to eliminate cases where it's reading the same key twice or anything like that. Switching to the actual web page, the first thing of interest here is that I open up a style sheet file called mediapanel.css, and this contains all of the styling information for the various panels on the info display. The actual main content of the page is in a collection of iframes, and before any web developers shout at me, yes, I know you shouldn't use iframes these days, but it's still effective. It worked for this particular case, and again, I just want to remind everyone this was 8 years ago. Now I've substituted out 2 URLs here. The weather station URL is actually linking off to the web page that gets produced by my weather station Raspberry Pi project. Similarly, the webcam's URL here is linking off to the web page I developed so I could see the contents of all of my different webcam feeds. Now both of these are covered in prior videos on this channel. I'm not for a second saying you have to use these or you have to implement those. If you've got some other place where you want to pull weather data from, or if you wanted to use these parts of the panel for anything else of your choice, absolutely you could go ahead. Obviously, I put this together with my needs in mind. If you want to have a panel at your house, make it display whatever data is right for you. The next page that this links off to is the calendar page. Again, this is really simple. I just provide some styling information from a style sheet, and then I link off to the URL of a Google Calendar. The way you get a URL for a Google Calendar is really straightforward. If you just navigate to calendar.google.com, hit the settings button here, and then go to settings. In the left-hand side, you can see the calendars that you have available. In my case, I'm going to select the Jeff's Pie in the Sky calendar. This opens up an option that includes this option here to integrate the calendar. If you click that, you then get this section here that provides this embed code, which is to an iframe. And all you want to do is copy that and then paste that right here in place of this marker. This will then make your calendar appear on your panel. The next thing I have here is a link to a page where I can get some status information about various devices that I've got around the house. Now I won't go through this in super detail, but in a nutshell, the way this works is that I have little agents sat on all of the machines that I want to monitor. They have a script that runs every minute that checks for something. Now my original use case for this, and the reason why it's called VPN status, is because I wanted to check the status of my VPN connection to another house. And so I had a script there that would say if the VPN was up or down and if it's working okay. It then just sends a very, very simple HTTP request back to this system. And then I've got some PHP code here, which will take some URL parameters from that and write that down into a file. The HTML here iterates through all of those different files and formats them into a table. If the file is showing that the status is okay, then that particular row in the table will be lit in green. If it's bad, it'll be lit in red. There's also a warning state as well that I use for anything that's based on time-based issues. For instance, if I haven't received a post from a particular system between about 1 minute and about 5 minutes, then I'll actually light it in yellow. And then if it's been more than 5 minutes, then I'll light it up in red. The next page that I link to here is for gathering news data. Now this is a little bit more complicated. If I go to the BBC News page here, you can see that there's a bunch of different news stories available, but they also provide this in a format called RSS. I'll put a link to this particular RSS feed in the description, but what you basically get from it is an XML document that contains a list of all those different news stories, and you can render these then however you want. So here I've got some code that parses out the channel information and some JavaScript that parses out the individual news stories. And this just lets me render whatever the most recent news items are from that RSS feed. And that's really all there is to my index.html page, the basic web page of the whole info panel. Here you can see the end result. I've got all of my weather information at the top, I've got my calendar in the middle, I've got my status information, and you can see that there is one thing there that hasn't posted me anything in over 5 days. I've then got some news feeds, and I've got my webcam feeds at the bottom. And this includes my AI-powered bird classification. If I hit the button on my panel to go to the next month, then you can see that the display flips to February. And similarly, if I hit the button for the previous month, then that goes back to January. If I hit the button to refresh the page, then you can see that the page refreshes. And if I hit the button to reboot the Raspberry Pi, it will reboot it. Now, because I'm capturing the screen right now using VNC rather than actual display capture device, I can't really demo it rebooting, but trust me, that functionality works just fine. Okay, so let's take a think about what is really good about this info panel. The first thing is that it does its job. And with any project, that is the most important thing. If something doesn't actually do what you've set out to do, then it's not fit for purpose. So in this case, I wanted something that would give me a lot of information in an easy to access screen, and it does that. In terms of its usability, I've just got 5 easy to use buttons on the front, and these are just bog standard push buttons that you could get anywhere. And there's a lot of flexibility over the content that I can display. I just need to edit the web page to make it show me whatever I want it to show me. But it's not all sweetness and light. There's also stuff that's bad about this project. Firstly, it's old, bulky hardware. Remember how thick that laptop screen is. Remember how much the circuitry protrudes from the monitor control board. And this just adds a requirement that the depth of the box has to be quite thick. The next limitation is the 720p screen, and this limits the amount of content that I can show on it. Now, 8 years ago, this was cool because it allowed me to get a laptop screen relatively cheaply to use for this project. But nowadays, with the abundance of full HD and 4K screens that are available, this is now looking very old in the tooth. And sometimes the functionality is a little bit iffy. I mentioned earlier that sometimes my webcam feeds stop, and sometimes I just find that the script that handles the buttons being pressed just doesn't work at all. And so I think the time has come that I need to look at new ways to achieve this particular project. And that's exactly what I'm going to be doing in part 2 of this video. I'm going to be repackaging this whole information panel in a completely different way. I'm going to be using a custom-made picture frame that I can use to hold a modern touchscreen laptop screen that is way thinner than the one I used in this particular version. This will allow me to get away from having physical buttons on the device at all and let me use the touchscreen technology to drive it. It'll also make the whole thing more interactive, as I could introduce such things as on-off switches for lights or something similar to that. It should make the whole thing a lot more flexible. Equally, because technology has moved on, not only is the screen smaller, but the control board for the screen is practically flat. And so the whole thing will be much thinner as well, and it will just aesthetically look a lot better. But I don't want to get ahead of myself here. I'll be covering all of this in part 2 of the video, so stay tuned for that. But that's it for this video. Once again, if you like what you see here, please hit that thumbs up button. Subscribe if you want to see more, and hit that notification bell so you can be told when I put out part 2 of this video, along with any other video that I produce. Let me know in the comments what you think about this project. Now granted, you may not want to take it on because in part 2 I'm going to be doing a lot of this with much better hardware. But you can probably pick up some of these older parts for ridiculously cheap prices now. And if you fancy a bit of a woodworking project as well, this is probably the one for you. But if you've got any ideas for other projects that you want to see me do in the future, put those in the comments as well. Thanks so much for watching till the end, and until next time, bye for now.